All right. Hello, everybody. Welcome to APIs for Server Admins, REST, Extract, TSM, OMI. I'm William.
And I'm Tom.
And we're both senior engineers with Tableau. I've also got my Twitter handle up there. Please give me a follow. It's not just nerdy data stuff. It's also nerdy hockey data stuff as well. So the Tableau platform enables developers to do all types of things on the Tableau platform, like implement custom data sources, integrate Tableau with other data science platforms, and embed your vizzes anywhere on the web, and as well as make extensions for dashboards. There are other sessions this week at TC18 that will go into all these areas, but today our focus is on automation. So your manager wants to know the adoption rate of what Tableau Server is. He wants to know when workbooks are created, how many are updated, and he wants it all in an email.
Or your marketing department suddenly tells you that they need 2,000 users provisioned for a conference next week.
Hard to believe. The sales team modified the calculation for what revenue is, and all the workbooks that use it need to be updated.
IT calls you and tells you that you're running out of disk space and you need to clear out a lot of your old content ASAP. We're going to walk through all of these scenarios and more, learning about the Tableau Server REST API along the way. Now, all of the slides and code featured in this talk are going to be available online, so don't feel pressured to take notes or remember every minute detail. Our first scenario is related to automated user provisioning. Now, here are a few scenarios where you might need to do this. As I mentioned, a conference, if you need to provision a bunch of accounts for all of your attendees. Or if you work at a university, you might need to provision hundreds or even thousands of users each semester. Or if you've just experienced a corporate merger, you might need to add accounts for all of your new employees. In this example, we're going to use Python and the Tableau Server client. Now, the Tableau Server client is the only officially supported client for the Tableau Server REST API. It wraps the underlying REST calls to Tableau Server, simplifying the process and hiding the low-level details, so we don't really need to worry about them. Now, the first step is to actually sign into Tableau Server. In order to do this, we're going to use the Tableau Auth class to set our user credentials. We're going to specify our username, password, and the site URL. Now, this is the name of your site as it appears in the browser after you've logged in. We're then going to use the server class to set the connection to the server itself. And we'll pass that Tableau Auth object to the server client sign-in method to actually log into Tableau Server. Now that we've logged in, we can create our user. We use the user item class to specify the username and the role, and then pass it to the server client's user's add method to actually create the user. Now, note that for Tableau Online, the username has to be the user's email address. Now, if the user is successfully created, the ID field will be populated with a uniquely generated ID by the server when the user was created. For on-prem, we're also going to want to call the user's update method to set the password. However, for Tableau Online, we don't need to do this, as Tableau Online automatically sends an email to the user with a link to an activation page that will allow them to set their own password. Finally, we can use the groups add user method to add the user to any relevant groups. Now, the process to create multiple users is pretty straightforward. We'll simply pull our user data from a file, a database, or an identity management system, or any other source. We'll iterate through this list. In the case of on-prem, we might want to generate a unique username. But as I mentioned with Tableau Online, we simply use the user's email address. We'll then execute that user creation code from the previous slide. And then for on-prem, we might want to email them a welcome message, but Tableau Online will handle that for us. So how do I get the Tableau Server client? The first step is to install Python. These links explain how to do so for Linux, Mac, and Windows. We then use pip to install the Tableau Server client. Pip is simply a package manager that comes bundled with Python itself. Now you're ready to go with Python and the Tableau Server client installed, and you can begin coding.
So the next scenario we're going to talk about is data source refresh. Before I get into that, I want to talk about tasks. Tasks are a grouping of a data source or a workbook with a schedule. The schedules define when the task runs. So you can imagine a scenario where you've got two separate data sources that depend on one another, or perhaps you've got a data source that depends on an ETL running. So what happens when you've got that dependency, and how do we ensure that our dependent task runs? So not featured in this code is getting all of the tasks. However, it is available online. So we're going to pick up right with the task ID, and we're going to use the task.getById method to get the task itself. And then finally, we're going to look at our dependency and see if it hasn't run by looking at the updated property. And if it hasn't run, then we're going to tell that task to run an update. So envision a scenario where you've got an ETL that's running, and you've got a script that does that for you. As soon as that ETL is run, you can then tell Tableau Server or Tableau Online, hey, my ETL is done. Let's update our data source in Tableau Server. So you can ensure that all of your content is up to date. So we've talked about REST quite a bit. But what is REST? So REST stands for Representational State Transfer. It is not a particularly helpful title. But for our purposes, we're going to define it as a set of rules for messages to be sent from a client to a server. And what makes something RESTful? It is stateless, it is lightweight, and the implementation between client and server is independent. Now, what does this mean? It means as long as you follow the rules set forth by the API, it doesn't matter what tools or technologies that you use to talk with a server, as long as you follow the rules governed by the API. So now we're going to get into migrating workbooks. And I'm super excited about this scenario because somebody in our hackathon on Monday was doing this exact same thing. And serendipity led us together, and we were able to do this for her scenario. So imagine you might have a staging and a production site, or a staging and production server, and you're using staging as a scratch pad for all your vizzes before you release it to the general public in your company. And you want to move those workbooks from the staging to production. Some things we need to know before we do this is workbooks are stored in projects. So we need to make sure that there is a project that we can put these workbooks in when we move it. We need to ensure, and we need to make sure we maintain ownership. Because if Alice makes the viz, then we want to make sure that Alice is still the owner of that visualization in our production server. So let's say somebody needs help with that viz, they know who to go to. We're going to do that using impersonation. Now, you need to be a server admin to use impersonation. So Tableau Online users, this feature is not available to you. But if you're on-prem, you can see I've got highlighted the user ID. And much like in Tom's scenario for user provisioning, that ID we get back from our created users, that's the ID that we're going to pass to this method. And this is going to, all subsequent requests that we make using this auth object are now going to be based on that user we're impersonating. So now we've logged in, and we've got our source server, or source site, and we've got our destination server. So these are two separate objects we've created using the Tableau auth and the server object that are either logging into two different servers or two different sites and different users. So we're first going to get all our workbooks, and we're going to get all the workbooks from the source server using workbooks.get. And then we're going to iterate through each of those workbooks, and we're going to download them. Now, the download method is going to return the file path for where that workbook is stored on your machine. This is actually going to download the entire workbook with an extract if it has one. So this could potentially be pretty large, so keep that in mind. And finally, here's our project mapping. Not seen here, but available online, is us collecting all of the projects in the source server and all of the projects in the destination server, and seeing if there's a one-to-one mapping based on the name of the project. So if there's a sales or marketing project in the source server, that it exists in the destination server. And if not, we'll just throw it in the default project, because that always exists. And finally, we've got our publish method. And this is really simple. Again, you're just going to pass it the workbook object, which you got from the source server. You're going to specify the file path, which you got from the download. And finally, I'm using an overwrite publish mode, so the destination server always has the latest and greatest workbook. So for security reasons, when you download a workbook and it has embedded credentials, those embedded credentials are stripped, so you're going to lose them. However, if you know that what those embedded credentials should be, You can always update the credentials with the Update Workbook Connection API, and you can get the connection ID with the Query Workbook Connection API. And we've got examples of this in our Dropbox.
So all of our previous examples used the Tableau Server Client. But what exactly is happening behind the scenes? What is Tableau Server Client really doing? In this next scenario, we're going to dive a little bit deeper into that. Now, within Tableau Server, users can subscribe to workbooks and receive daily emails with the updates to those workbooks. So let's say you have a new server admin that's joined your team, and he or she needs the same subscriptions as your existing server admin. We're going to use the Tableau Server REST API to copy the subscriptions from the existing admin user to the new one. And we're going to do this the hard way, using Python, but without the Tableau Server Client. So why do we want to do this? To make more work for ourselves? Well, for this example, we're going to do it to learn about REST and see what's going on under the hood with Tableau Server Client. As William mentioned, REST works by sending messages from the client to the server. These messages are typically in one of two formats, JSON or XML. Now, if you're not familiar with either, they are simply text formats for representing structured data. We are going to use JSON. It's a lot easier to work with, and it's much more commonly used these days. And in this example, we're going to build our JSON requests manually and send them to the server. So the first step in the process is to get the user IDs. Now, all REST requests have several components. They have headers, they have a URL, and they may have an optional data payload. Let's start with our headers here. First header you see is this X Tableau Auth with a token. So what is this token, and where's it coming from? Well, we got to look into the Tableau Server sign-in process to understand that better. Now, Tableau Server requires that all REST calls contain an authentication token. Now, in order to get this, we need to make a sign-in call to the REST API. We're going to make a post to the sign-in endpoint. We're going to use the request payload on the left, which you'll see contains the username, the password, and the site URL. And as I mentioned earlier, this is the name of your site as it appears in the browser URL when you log in. We'll then get a response from the server that includes a numeric status code indicating success. It contains the site with its unique ID, the unique ID of the user that just logged in, and most importantly, this authentication token. We then need to include that token as an HTTP header in all future requests. Now, by default, the token's good for 4 hours, but this is configurable in your Tableau Server settings. And this is a very good example of something the Tableau Server Client handles for you. After you log in with Tableau Server Client, it stores this auth token and automatically sends it with all future requests. But in this example, we're going to be doing it ourselves. So back to the example. We need to get the ID of the user from which we are copying the subscriptions. Now, in addition to the authentication token, headers can specify the format of the message payload and the expected response. Tableau Server actually defaults to XML, so we're going to explicitly tell it that we are sending JSON and we expect JSON back in a response. We're then going to build the URL to our REST endpoint, make the request to Tableau Server, and then check each response contains a numeric response code. So we want to check that for success. Now, let's also look at that URL just a little bit deeper before we move on. Now, REST endpoint URLs have several components. They've got the base URL, and you can find this by logging into your site online and looking at the first part of the URL in the browser. There's an API version. Now, versions lock an API, guaranteeing the format of the messages. If the message formats change, the API version is incremented. Here, we're specifying the current Tableau Server REST API version, which is 3.1. Note that some REST APIs actually specify the version in the header, but Tableau Server expects it in the path. REST endpoints also use nouns to specify the resources upon which we're acting. In this case, we're querying for a site. So we also need to specify the unique site identifier. Now, if you recall, this was returned in the response to the sign-in request. We're also going to add the user's noun, since we're querying for users on a site. And you can optionally specify filtering and sorting. In this case, we are filtering on the name of our admin user. So now we need to get the subscriptions belonging to this admin user. The Tableau Server REST API doesn't actually allow you to directly query for subscriptions for a specific user, so we're actually going to get all of the subscriptions for a site. We're going to set our authorization and content type headers, make the request to get all of the subscriptions. We're then going to iterate through each subscription and check to see if the subscription belongs to our source user. If so, we're going to create the request JSON to create the subscription for the new user. So here's what that request JSON would look like. We specify the name of the subscription, the content to associate with it. This will be a workbook or a view. The schedule to associate with the subscription, and the user that is subscribing. In this case, it'll be our new admin user. So how do we build this JSON? Python actually contains a library that will build the JSON for us. All we need to do is create an associative array with the request data, and then call the JSON dump method that will generate the JSON string we can use as our payload. So returning to our example, we've built our request JSON to create the new subscription. We'll set our authorization and content type headers, and then make the call to create the new subscription, passing in the JSON request payload. Now let's talk a little bit about the protocol that REST uses for these messages. REST uses HTTP. This is the same protocol used for web browsing. All HTTP requests use verbs. These are get for query, post to create, put to update, or delete for removal. You're going to use the appropriate verb for the action that you are requesting. In this case, we're using get to query the subscriptions and a post to create the new one. Finally, all HTTP responses include numeric response codes, such as 200, which means OK, 400 indicates you made a bad request, or in this case, 201, which indicates something was created on the server. So we learned a few things about HTTP here. All HTTP requests have headers. These are used for authentication, content type, and API versioning. That content type is typically JSON these days, but can also be XML. Each endpoint contains a server URL, optionally an API version, the resources upon which you're acting, and any optional filtering or sorting. Each request uses a verb, get, post, put, delete. And all responses contain codes that equate to things like OK, created, no content, bad request, or not found.
All right, so you may have heard in the devs on stage, we're going to be adding webhooks to our API. So I'm going to go into some brief detail about webhooks and what they mean for polling scenarios. So if you wanted to know every time a user created a workbook on your Tableau server, you would have to continually poll Tableau server and say, hey, are there any new workbooks? Hey, are there any new workbooks? Webhook is going to allow Tableau server to tell us when that happens. So we don't have to continually poll Tableau server. So as we mentioned earlier in the talk, the tools and technologies we use don't matter as long as we follow the rules set forth by the API. So I'm using PHP here and a client called Guzzle that will talk with the REST API. Something to note is I'm using the experimental API version, which is notified by EXP. So as Tom mentioned, the API version will lock down the messages that are sent to the server. EXP is basically giving us free rein to not follow those rules. So anytime that you're using the experimental API, you can expect that there'll be lots of turnover. So if your script worked one night and the next it doesn't, just refer back to the documentation, because we could have added a feature, fixed a bug, that sort of thing. So this is me signing into Tableau server using PHP. I'm setting the headers, much like with the subscription scenario, setting content type to let the server know we're sending JSON, accept header to let it know we want to receive JSON. And finally, Guzzle's got a nice little feature that allows me to pass in an associative array, and it will generate JSON for us. So you can see this looks extremely similar to the sign-in JSON. We've got the username, the password, and finally the site that we're logging into. So this is what the webhook JSON looks like when we want to create a webhook on server. We've got the name of the webhook. We've got the event for the webhook. I'm not sure why our boxes are off there, but that's fine. And all of these workbook events, they're all in the documentation because they're kind of hard to remember. And finally, we're going to specify the destination that we want Tableau Server to let us know when this event happens. So we're saying it's an HTTP event. We want to post. And finally, the URL that the webhook is going to be sent to. And now we've got the payload. So this is what Tableau Server is going to send to our webhook. We've got the event type, which is workbook created. We've got the name of the workbook that was created, the site name, or sorry, the site ID, which is a UUID, and now we've got this resource ID that looks like a number. So that resource ID is actually supposed to be the workbook's UUID. Remember what I said about this being an experimental API? This is actually a bug currently in webhooks. And this should be the workbook UUID because that's what we use when we access resources in our API. We use the workbook UUID. So this number 99 here isn't particularly useful to us. A subsequent bug fix will fix that so we actually get the actual object ID instead of the resource ID. And finally, we've got the request that we're making to Tableau Server to create the webhook. So we're using the site ID, and we're posting to the webhook's endpoint on the site. And finally, we're building that JSON. You'll notice that this looks very similar to the JSON from the previous from the slide 2 slides ago. We're setting the destination. We're letting it know we want the post verb and our URL.
So let's say you're running out of disk space and you need to delete some old unused content. You also don't know Python, you don't really like Python, or you just don't really want to learn it.
Boo, Python.
In this example, we're going to use Java. As William mentioned, the REST client and server implementations can be completely independent of each other. And there exist REST libraries for a variety of different languages. In this example, we're going to use Spring's REST template library. It's included in the Spring Web package, which is part of Spring Boot, which we're going to use to make our application runnable. Now, do you remember exactly what that sign-in JSON looks like to log into Tableau Server? Probably not. Here's a quick refresher. It simply contains the username, the password, and the site URL. Now, to create this JSON payload in Java, we're going to use the Jackson library and annotated classes. So here's what our credentials class would look like. The first annotation tells Jackson that when deserializing JSON, ignore any JSON that doesn't match the fields listed below. This is very useful when using the experimental API. We also only want to serialize fields that have non-null values. And we want to wrap the whole thing in a top-level JSON credentials field. Lastly, we will define the actual fields and getters and setters for each. Now note that we'll have similarly annotated classes for the site and user object. We're then going to use REST template and this annotated credentials class to send the request and parse the response to log in to Tableau Server. So first, we create our credentials object. We're going to populate it with the username, password, and site URL. We'll then create a REST template object. And we're going to post to the sign-in URL using the credentials object as a payload and specifying that we are expecting a response that can also be deserialized into a credentials object. Now, in this example, both the request and the response are represented by the same class, but this doesn't have to be the case. However, whatever class you specify for your response must be one annotated such that the response JSON you get back from the server can be deserialized into that object. Finally, we're going to get the auth token from the response. Now, here's the code to actually prune the old workbooks. First, we're going to make the call to get all the workbooks for the site. We're going to make sure that that list is sorted in ascending order by the updated @ field. We'll then iterate through all of those workbooks, check to see if each workbook is older than the specified time window. If so, we'll add it to the list to delete. And if not, we're going to stop processing as we've reached the workbooks that are no longer considered old, since this is a sorted list. Now, note that I've glossed over a little bit of code here. This is all related to pagination. Now, Tableau Server doesn't automatically return all of the results to our queries. This can be a really long list with hundreds or even thousands of responses. Instead, it uses pagination to return these results in batches. So each query response is going to contain a pagination element. Now, this contains the page number. Now, note that this is not zero-based, so it's going to start with 1. The number of items per page, and the total number of items that the query actually returns. We can then use this to page through our result set. And in Java, we'll accomplish this by incorporating a pagination class, properly annotated, into our response classes so we can access this pagination data. So how would we actually page through these results? Here's a very basic example. We're going to first look at the total number of results, and then we're going to check to see if that is greater than the number of the current page multiplied by the number of items per page. In other words, how many items have we gotten back so far? If it's greater, then we know that there are more results to view, so we're going to want to increment that page number and get more data. Otherwise, we'll terminate the loop. So back to our example. Now that we have all of our list of workbooks to delete, we simply iterate through that list and make a delete call to the site workbooks endpoint to remove the workbook. Now, why do we query all the results first before deleting? It's basically due to caching. If we're paging through the query results and actually deleting along the way, it's going to impact the results that are returned, and we might miss some items. So instead, we retrieve all of the data, process it to find everything that we want to delete, and then actually delete the entries.
So the next area we're going to talk about is changing the content owner. So much like deleting workbooks, we could delete users, and what if we want to delete a user that owns hundreds of workbooks? Tableau Server won't allow you to do that. So we're going to get the workbooks, all the workbooks a user owns, and then we're going to transfer ownership to another user. So much like in the subscriptions example again, we're going to need to get the user. And because I'm going to be getting both the owner, the current owner of the workbook, and a new owner to transfer ownership to, I've created a function here that will allow me to reuse some code that will get the user using a filter. And we're also going to make sure that using the pagination object, there's only one record returned, because we're looking for a specific owner. So if we get multiple results, we probably need to refine our search a little bit. And finally, it's going to return the user. This is what that JSON is going to look like. We've got our pagination, and then we've got the user that's returned. It's got the ID. This is the most important part. But it's also got the name, the site role, and other properties. So now that we've got both our owner and the user we want to transfer ownership to, we're going to get the workbooks for that user. So you can see I've got 3 different nouns in our URL. We've got sites, users, and then finally workbooks. And then we're going to iterate through each workbook. And we need to update each workbook using the put verb. And again, Guzzle is going to allow us to pass JSON using an associative array. So we're setting on the workbook, the owner, and the ID of that property to our new owner. And now, all of the workbooks have been transferred, the ownership of the workbooks have been transferred, and now we can finally delete that user from Tableau Server.
So for our next example, we are going to create a daily email that lists all of the workbooks with updates over the prior 24 hours. Now, everybody's using the cloud these days, so we're going to try that as well. We're going to use AWS Lambda to automate this process serverlessly. Lambdas run in the Amazon cloud on demand or via schedule without provisioning dedicated server resources. We're going to create a Lambda written in Python using the Tableau Server client that runs nightly. Now, in order to do this, we'll use the AWS Web UI. We're going to navigate to the Lambda service. We specify we want to create a function. We want to author it from scratch rather than using any of the pre-existing templates. We'll be using the Python 3.6 runtime. And we need to specify or create an IAM role under which that Lambda is going to run. This will then take us to an editor page where we can enter and edit our code. And here's what the basic code for that digest would look like. We're not going to dive too deep into it here, but the full content is available online in our code repo. So all Lambdas require a handler entry point that take an event and context as parameter. Once we're inside the Lambda, we're going to get all the workbooks sorted by the updated at field in descending order. We will iterate through those workbooks. And if the workbook has been updated within our specified time frame, we're going to add it to the daily digest list. We'll exit the loop if we've reached the last page of results. Otherwise, we are going to increment the page and get the next page of results. Not shown here is the code to actually send the email, but that's in the code repo as well. Now, we also need to specify a frequency at which this Lambda is going to run. We need to tell AWS when to run it. We'll also use the AWS Web UI. This time, we're going to go to the CloudWatch service. We want to create an event rule. Once we're in there, it lets us specify a schedule. You can either set a fixed rate or use a cron expression. For our example, we'll just use a fixed rate of 24 hours. We're then asked to select a target, which will be the Lambda function we just created. And we're done. The Lambda will now run our Python code nightly, querying Tableau server for the updated workbooks and sending out the digest email.
So at the start of the talk, I mentioned that what if the calculated field for revenue changes and you want to update all of the workbooks or notify the owner of those workbooks that that calculated field has changed. We're going to be using the document API along with the Tableau server client. So the document API, what is it? It provides a means to extract information from our TWIB files. So we can get things like dimensions, measures, workbooks, views, and fields. This is awesome because there are no more manually editing XML files. Nobody likes editing XML files. And we're not going to make any XML mistakes. So as I mentioned, we can tag all the workbooks that use a specific field. We can report on workbooks that are even using outdated data sources. We can email owners of those workbooks and let them know that calculated fields need to be updated. So the first thing we're going to do is we're going to download all our workbooks again, similar to the Migrating Workbooks. We're going to get all our workbooks and then iterate through each one. We're going to add them to a list so then we can process them later. And finally, we download them. Now, here's where this particular scenario is slightly different from Migrating Workbooks. We're going to set the no extract equals the no extract flag to true because we don't need the data. We just need the workbook itself. And this is actually going to make it so the workbooks that you download are much, much smaller. So here's where we're going to introduce the Tableau Document API, and we're going to import the workbook in the field object. This is where things can get a little tricky because both the Tableau Server client and the Tableau Document API, they use a lot of the same words or class names. But the Tableau Server client will use a suffix of item in a lot of its classes, so a workbook item or a data source item and the like. Finally, we're going to open the workbook using the file name. Again, that file name gets returned from that download method. And then we're going to go through each data source in that workbook, because there could be more than one, each field in those data sources. And if that field equals a name that we're looking for, we can tag the workbook, add it to a list so we can do some processing later. And finally, we can update the workbook. Let's say we want to change what that calculated field is. The Tableau Document API will allow you to do that. So now we're going to be checking on server health. Checking server health, we're going to be using TSM, which stands for the Tableau Services Manager. Now, our hosted solution, Tableau Online, you guys won't be able to access TSM. But for those who are using on-prem, you can use the TSM API to check server health. Remember what I said about REST APIs being stateless? TSM ignores all that. Sorry. And when you log in, you're going to get a login cookie that you will then need to send much like a header. So this cookies flag will allow me to, or rather Guzzle has a feature that allows me to specify this flag to true, and it will send the cookies automatically for me. Okay? So if you're using another language or technology, you will need to make sure that you get the cookies from the response and then use that cookie in all subsequent requests. The login method is at the bottom, and it looks very similar to logging into Tableau server, only a little simpler. We just have an authentication object with a name and a password. So now we're getting to get the nodes and their status. So much like accessing the Tableau server REST API, we're accessing the nodes now, and it's going to return all of the nodes and their ID. Then we're going to iterate through each of those nodes, and then we're going to get the status of those nodes using the ID that we got. Now, in this example, I'm just printing out the status of the node, but you could potentially have a server health dashboard that goes through each node, and if its status is green, you can have a nice little traffic light there that has green, and if there's something wrong, there could be a big red danger button or the like. And finally, I'm going to talk about the extract API. So the extract API is really easy to use. It's lightweight, around 1 megabyte in total. The extract consists of tables and rows only, and it can generate a TDE or hyperextract. So this will allow you to curate your own data, create an extract for other people in your company to use. The SDK comes in 3 languages. We have it in Java, C, and C++. This one line, okay, and this is in Java, this one line will create our extract. It's, as I mentioned, it's very easy to use. This file, as soon as you call this method, will actually generate the file for you. And as you notice, I'm using the hyper extension to let the extract API know that I'm creating a hyper extract. So now we're going to define the table that we want in our extract. So I'm going to be using the table definition class. And I'm going to define things like the ID column, which is an integer, the name column for the employee's name, their position, and their start date. And finally, I tell the extract API to add the table and what its name will be. And now we're going to insert rows. So we're tell the extract API that we want to open the employees table. Now, when we create a row, we need to pass in the table definition so the row knows what format it's supposed to be. And then we're going to use a zero-based index to set all of the fields on the row. So the 0th row will be the ID, the first, the name of the employee, the second, their position, and then finally the last field, their start date. And I'm using the setDate method there to set it to January 1st, 2018. And then we're going to insert our row into the table. And you don't even need to do anything else after this point. The extract has already been saved. There's no calling an extract.save method. You're literally editing this extract on the fly. And this extract can easily be opened into Tableau Desktop, and you're all set. So now we've gone over a lot of different scenarios. We're going to give you some resources to help you debug your own automation scripts. Postman is a UI that will allow you to test REST APIs. Just as we mentioned, the client and server are independent of one another, so as long as you follow the rules set forth in the API, you can use Postman. If you're like me and you're a little more friendly with the command line, VS Code is an IDE, and the VS Code REST client is a little more similar to the command line, looks a little more hackery. Some useful libraries, as we mentioned, the Tableau Server client is the only officially supported client that we've got. If you like Java, as Tom used in his examples, we've got the Spring REST template. Oh yeah, don't worry about memorizing these URLs. It's all available in our slide deck that will be available in the Dropbox, which we will mention in a little bit. PHP's Guzzle client. And finally, we've got a GitHub with some REST API samples. So you can see all our samples in Dropbox, and then there's several other samples in the Tableau GitHub repo. Finally, everybody loves documentation. So we've got documentation on the REST, extract, TSM, and document API. They will give you all of the nitty-gritty details. And I mentioned the experimental API. That will be in there as well, so you can see all the latest and greatest features that we're going to be putting out. Right. There we go.
Here are a couple related developer sessions. The schedule and exact locations can be found in your TC app. And here's some resources that you can use if you want to follow up and dig a little deeper. First of all of the content in the TC Developer Track sessions is in this Dropbox folder. There's a subfolder there for our session, and we've added the slides along with all of our sample code. Now, as you heard on Tuesday, we've also got a brand new developer program that gives you access to a free dev site, early access to APIs, such as the experimental API, tools, samples, and more. Tableau also has a home on GitHub. We've got a growing number of projects there, including tools such as Tableau Server Client, APIs, and sample code. Please complete the survey session when you get a chance. Not only will this help us as speakers, but it's also going to help determine the content for next year's Tableau conference. So I'll put this slide back up there so everyone can take note of the URLs, and we'll open the floor to any questions.
So is there any limitation between Windows Server and Linux Server Tableau Web Server for these tools?
So the question is if there's any limitation between Windows and the Linux version of Tableau Server in terms of interacting with it with the REST API? So as we mentioned, since the REST really just defines the message format and the client-server independent, Windows and Linux will respond the same way. So the tool sets, you're really representing a client talking to it. So it won't matter which, if it's Windows or Linux.
Oh, yeah, the extract API. Oh, sorry. The question was, can you read hyperfiles? Yes, absolutely. The extract API will open up a hyperfile as well. I believe you can go through every row in your extract, both TDE and hyper.
So extract is used to get data into Tableau Server. Do you use that to get data out of Tableau Server?
That's a good question. So as I mentioned, you can iterate oh, sorry. The question was, can you use it, the extract API to get data out of Tableau Server? So again, you're only going to be able to get data out of the extract itself. But yes, absolutely. You can use the extract API to open the extract and iterate through all the rows. I believe so. Sorry, the question was the Tableau Document API doesn't appear to be up to date. Do we support the latest TWIB files? I believe so. All of the Tableau Document API should be we've got a team dedicated to that, so it should be updated at the same rate when we release new features. If there's a feature that's not there, definitely go to the developer program, submit your feedback. And harass us, because we'll get it done. Yep.
When publishing back copies of the API, is there a way to not publish the sheets that are not hidden but are technically published?
Oh, OK. So the question is, when you're republishing a workbook, if you can remove some of the views from that workbook. You could use the document API to open that workbook, remove the views, and then use that new file to upload. Right.
Download all the workbooks.
Mm-hmm.
But some of our users tend to leave all of the sheets there. They only see 3 dashboards and everything else. And, say 50 sheets are in the workbook. And if I publish that to another site, it'll bring all of those sheets with it.
Oh, yes, it'll absolutely bring all those views with it.
Identify what is actually published.
Oh, I see. So you're looking for, so the question is, can you look at when individual views are updated?
So if I'm moving a workbook from one site to another, make sure that I only publish to the new site what was available.
Oh, yeah. So you can use the API to only get workbooks that were updated in, say, the last week. And then those are the workbooks that you would then publish.
Is there an attribute on the tab, the view?
Oh, the individual.
Workbook that has, is hidden or not?
So the question is there an individual attribute on each individual view of when that view is updated? That.
If it's hidden.
Oh, if it's.
Like you go to publishing site, only dashboards, or something like that.
Oh, I don't believe so, no. I don't believe if a view is hidden. However, Tableau Public does allow you to hide tabs, so I'm wondering if there's something similar there. If you're willing to stick around, I could get your email and I could see if I could follow up with you on that.
Do you have any plans to add the ability to
So the question is, do we have any plans to add collections of users? So you could potentially use groups for that. So if,
I'm talking about like when you're adding users to the server with REST API.
oh, bulk.
Yes.
A bulk.
If you're adding 18,000 users, you don't want to have to iterate through that.
Absolutely. So I don't know if there are any recent plans, but we know internally that that's something we need to do. The fact that you're here and you're requesting it is great. So I will definitely follow on that feedback. And again, if you'd like to give me your email afterwards, I can take it down and make sure that you're notified when that happens. So the question is, using the document API, is it possible to get filters in the parameters? I 100% know filters you can, and I don't see why there wouldn't be a reason to get, we wouldn't be able to get parameters. Yeah. Yeah. Yeah, I see no reason why parameters also wouldn't be there.
So follow-up question, can you like do a bulk delete if you have like a list, like text file list of users?
So the question is, can you do a bulk delete? No, but again, the fact that you're asking just means that we need to add that. So I'll definitely follow up with that. Yep.
Is the document API released yet?
Yes. As I mentioned, when you download the slides, there's a link to the document API documentation. You can absolutely download that. It's currently only in Python, though.
Oh, okay.
All right. Thank you very much, everybody.
All right, thank you.